Hello friends, welcome to Susan and John MathTube. This is lesson number 8 in the exam preparation series for first year, first part engineering students. And as always, the most important question, how to use video lessons effectively. And I'm sure you know that. Always be ready with pen and paper before you start the video and make sure you work out all the problems along with us. And the most important thing, once the video is over, make sure you refer a book and work out a lot of questions. And with that, let's start properties of definite integrals. In this video, I'll give a rough idea of the properties, and from the next video onwards, we'll be doing numericals. But remember, the theory part is very important, especially for the students who are not that familiar with the geometrical meaning of integration. Okay, let's start the story with a small graph, and I'm sure that you're familiar with the graph of f of x is equal to x square. You might have learned about parabolas in class 11 and 12, so I'm sure you're familiar with f of x equal to x square. Anyway, let's try to plot by putting some values and getting the outputs. For example, if I input 0, I will get the output 0 square. So that gives me the coordinate 0, 0. And if I input 1, I get the output 1 square. And if I input minus 1, I get the output minus 1 the whole square, that is 1. Similarly, for 2, I get 4. And for minus 2, I get 4. And I get 3 and 9 and minus 3 and 9 and many points in between and after this. This is more than enough for me to plot. So here we go, 0, 0, and let's assume this is 1. So this will be our 1, 1, and this will be our minus 1, 1. And as expected, we get a parabola. I'm not going to plot more than this. So I wanted to take a very good look at this graph. So look at this. At every point, you have to understand the function value will be the height of the graph. The function value will be the height of the graph. For example, if I want the height of the graph at x equal to 2, then I know that is 4. So look at this. The height of the graph at sharp, my graph is not accurate, that's why I'm not getting the exact value, but it's just a rough graph. Okay, so remember, if this point is 2, then the height will be 4. And likewise, I'm able to generate many height here. If it is 1.5, I'll get a height 1.5 square, that is 2.25. At 1, the height is 1. At 0.5, you will get another height. So remember, the function value corresponds to the height of the graph. I'll repeat once more. In a function y equal to f of x, the function value will be the height of the graph. Now look at this. Suppose I integrate from 1 to 5 x square dx. So basically what this implies is there is a point x in general. And of course I told you the height at that point will be x square. I don't know where is this x, but it is between 1 and 5. And the height of the function at that point is x square because we are using the function x square. If you are using sin x, then the height will be sin x. If you are using the function cos x, then the height will be cos x. And now let's imagine the small, I will take a pretty decent strip so that you understand easily. So look at this. Let's say this is x. And at x, the height is x square. And I hope you're able to see a rectangle here. You're able to see a rectangle. And imagine this is something which I have magnified millions of times. So what I am trying to convince you here is, at x, you can see a rectangle of height x square, and let's say the width of the rectangle is so small, I can call it dx. That means this x square into dx will be the area of that rectangle. I hope you got the point. So that means if you add all the values, like if you put 1, if you put 2, if you put 3, if you put 4, if you put 5, and by the way, what is integration? You might have learned in your plus 2 and all. Integration stands for summation, continuous summation. That means all the numbers between 1 and 5 should be included. And remember, no one can make a list of numbers between 1 and 5. I am talking about real numbers. I am not talking about integers 1, 2, 3, 4, 5. So, you have to input, I'll tell you one more thing. There is another summation, sigma. If I say sigma 1 to 5 x squared, then it stands for discrete summation. This means 1 square plus 2 square plus 3 square plus 4 square plus 5 square. That's it. But when we do integration, that's nothing but the letter S. It's the letter S a little bit pulled out. Okay, so when I say integral 1 to 5 x square dx, it's like adding all these lines. At every point, I told you, at every point, a height will be created with the help of the function. So, what I am trying to convince you here is a very simple thing. Integral f of x dx from a to b is a summation. It's basically summation. Let's imagine, for the time being, let's imagine f of x is a positive function. Means the graph will be always above the x-axis, like our function x square. And let's say this is a and this is our b. And you saw earlier, at every point we got the function value. Earlier our function was x square, so every time it got squared. But generally it won't be x square. It can be sin x, it can be x cube, it can be anything. Anyway, at every point you will get height. At every point. So basically when you try to do it, it will kind of like, it will be like this. There will be so many things, so it will cover the entire area. Okay. So, integral a to b stands for continuous summation of all the function values. And remember, there is a misunderstanding, especially in class 11, most of you might have learned definite integrals, and immediately after definite integrals, you might have learned that integral stands for area, and that is wrong. Look at this. Integration is summation, and summation may or may not be the area. I'll prove it in a minute. So let's take the graph of sin x. And sin 0 is 0, sin 90 is 1, sin 180 is again 0, and I'm sure you're familiar with the graph of sin x. Now look at this. Suppose I want to integrate from 0 to 2 pi. That means I want to add all the function values from 0 to 2 pi sin x dx. That means the height generated at each point multiplied by the small length. That means we are creating infinite number of small rectangles. For example, at 90 degree, I'll get a rectangle whose height is 1, because you know sin 90 is 1. And this is so small, that will be our d at 1. And at 270 degree, I will get minus 1. Now tell me, what will happen if I add 1 and minus 1? So look at this, 1 plus minus 1 will be 0. Similarly, that is easy to point out, but similarly, if I calculate the height at other points, let's say at 45 degree, I got 1 by root 2. At the same time, at 225 degree, I'll get minus 1 by root 2. See? And when I add 1 by root 2 and minus 1 by root 2, again it gets cancelled. So the value of this integral, you can use the technique which you learned long back, will be equal to 0. But at the same time, I cannot say the area is 0. Look at this. There is so much area. And by calculation, the area comes around like 2 plus 2, 4 units. So we cannot comment that integration is equal to area. So remember, the proper definition of integration is addition of function values in a continuous manner. So what is integral a to b? You are adding all the function values. That's it. And if the graph is, for example, let's integrate from 0 to pi sin x dx. Yeah, in this case, you will get the area of the graph because the graph is completely above the x-axis. Look at this, the graph is completely above the x-axis, so you are going to get the area. And you can even use your previous techniques like cos x and 0 to pi, and then you plug in that upper value that gives you -1, that will be 2. And I told you, the total area is like 2 plus 2, 4 units. But at the same time, look at this, integral 0 to 2 pi sin x dx equal to 0. So I want to clear one misunderstanding. Integral a to b f of x dx may or may not give you the area. Basically, you have to understand this is the summation of all heights of the graph, height or depth. Okay, now with this approach, the properties are very easy to study. Let's start with the first property, integral a to a f of x dx. Can you guess graphically what will be integral a to a f of x dx? If you guess, you're really smart, that is 0, because basically you're not adding anything. You start here, you end here, so you're not adding anything, so you're not going to get anything, and mathematically we write is equal to 0. Now let's look at another property, like integral f of x dx, we add from a to b, and I want to interchange the limits, and I cannot call them equal anymore because those who know like rather than the geometrical method, the calculation method will make you understand this property very easily. Look at this, I am going to calculate integral 1 to 2 x square dx. So I am going to get x cubed by 3 within the limits 1 to 2. Now what I do is I plug in the upper limit 2 cubed by 3 minus 1 cubed by 3. At the same time, if I perform the calculation integral 2 to 1 x square dx, and then what happens is I'll be plugging in 1 first, and then I'll plug in the value 2. So that explains the property, because a minus b and b minus a are exact negatives of each other. Okay, so I hope you understood that part. Okay, now let's move on to the next property, and that will be very easy to understand geometrically. But first of all, you must answer me, how many numbers are between 1 and 2? How many real numbers are between 1 and 2? Are you able to list all those numbers? Can you make a list of all those numbers? If you remember what you learned in class 11, you will give me the answer no. And that is why you learn something called open intervals, closed intervals, etc. Because no human being will ever be able to answer or list all the numbers between 1 and 2. If you tell me the next number is 1.000000001, naturally by putting one more 1 I can create more numbers. So believe me, there are infinite number of numbers between 1 and 2. Okay, now look at this. I want to integrate between a and b. Okay, so like what we saw earlier, this is nothing but addition of all the heights. Okay, wait a minute. Let's say this is a point C, not in the middle, somewhere between. So I'm going to write this as integral a to c plus integral c to b. That means you can split the integral, I mean definite integral, at any point in between. At any point in between. Geometrical, it will be very easy to understand. Okay, now let's move on to the next property, and that is very important. Very important in the sense, most of the questions they ask for your exams are related to this property. And this will be very easy to understand with the help of the following example. Okay, I'm going to keep the domain value. Domain value means input value. And I'm going to consider all the numbers between 0 and 5. I'm really sorry I'm not able to make a list out of all the numbers between 0 and 5 because it is humanly impossible. Now I'm going to write x square here. I'm going to write the function f of x equal to x square. And just beneath, I'm going to create a function f of the final point minus x, because I'm considering all the numbers between 0 and 5. I'm creating the function f of, because look at this, f of a minus x means the f of last number minus x. So 0 squared will give you 0, 1 squared is 1, 4, 9, 16, 25. And now I have to plug in this function. So if I plug in 0, I will get 25, 5 minus 1, 16, 9, and then 4, and then 1, and finally 0. And in between there are many function values. I'm not able to list all those function values, but I'm sure you'll be able to understand with these values. Now look at this. Integration means addition. Now think about it. If I add all these numbers, what will be the sum? And my question is, what will happen if I add all these numbers in the last row? Won't it be same? Okay, so you have to understand one thing. The function f of x and the function f of a minus x in the domain 0 to a, that means the input values 0 to a, will be the same, but the values will be generated in a, opposite sense. I don't know if the word opposite is apt here, but I think you understood. The first value you get here will be the last value here, and vice versa. And that means if you add this from 0 to a, or if you add this from 0 to a, you're going to get the same value. And this is one of the most important properties, and the problems we will do in the next video. Okay, now something very similar to this property. Integral a to b f of x dx is integral a to b f of a plus b minus x. The explanation is similar. You have to check the function f of x and f of a plus b minus x, and you'll see that they generate the same values between a and b, and hence the summation is easy. Look at this. The key point is integration means continuous addition of function values. Once you understand this, you'll understand all the properties. And I'll repeat, if you want regular proofs, those proofs are available in your books. So in this video, I'm trying to make you understand the geometrical meaning, because that will make you a little bit more powerful than learning the regular proofs in a regular manner. Okay, now let's go for the next one, even and odd function. Okay, now look at this. Same thing. In class 11, you had a topic called curve tracing. And in curve tracing, you learned about even functions and odd functions. Look at this. The best example for even function is again our x square. If you replace x with minus x, what happens is that minus will disappear, because you're going to get minus x the whole square, and you're going to get the same function. So basically, even functions will be symmetric about the y-axis. The logic is very simple. You input x or you input minus x, you're going to get the same value. Look at this. In the case of x square, it's very, very easy to visualize. You input 1, the output is 1 square. You input minus 1, the output is 1 square. So the coordinate will be reflections. So you input 2, you get 4. You input minus 2, you get 4. That is exactly what you mean by saying f of x and f of minus x are both the same. So you input the value here or you input the value here, the function value will be same. So the graph will look like this. That is symmetric about y-axis. Now imagine you're going to add all the values from minus a to a. Imagine you're going to add all the values from minus a to a. Now what happens is, you're going to get the same answers. So my conclusion is, integral minus a to a f of x dx will be 2 times 0 to a f of x dx. Think about it. Think about it. If I add all the function values on this side and multiply by 2, I'll get the total value from minus a to a. I'll give you one more example. That is an even function of an even function, that is cos x. And I'm sure that you know cos minus theta is equal to cos theta. And what it implies is, we get something like this for the graph of cosine. It goes like this. And let's say I'm going to integrate from minus 90 to plus 90. And you can see that very clearly. This sum, the sum of all the heights, will be equal to this sum. So integral minus 90 to 90 cos x dx is the same as 2 times 0 to 90 cos x dx. Okay, that's it. Now let's move on to odd functions. Odd function means f of minus x will be minus f of x. That means minus will jump outside. And one of the easiest graph to understand this is x cube. If you replace x with minus x in x cube, that you can see that minus will jump outside. And I'll make you understand geometrically. 0 will give you 0 cube, that is 0. 1 will give you 1 cube, that is 1. Minus 1 will give you minus 1. So what happens is, you get 0, 0 over here. And for 1 you get the graph here. And for minus 1 the graph will be somewhere here. And for 2 you get the graph at 8. And for minus 2 you get the graph at minus 8. And correspondingly there will be many values in this side, and you'll keep on getting values. And I can see the graph coming out. It's called semi-cubical parabola. And my question is very simple. If I add from minus 1 to 1 x cube dx, can you tell me without integrating using the techniques the answer? Yeah. This is minus 1, this is 1. This is minus 1 by 8. At minus 1 by 2 the output will be minus 1 by 8. And at 1 by 2 the height will be 1 by 8. So the total value will be 0, because corresponding to each depth there will be a height. And if you add them up, you get the value 0. Now let's make a conclusion. Integral minus a to a f of x dx is equal to 0 if our function is odd. Because the logic is very simple. The graph will be half above the x-axis and half below the x-axis. You can think about the graph of sin x. The graph of sin x is also an odd function. So if you do addition on both sides equally, the answer will be 0. And suppose f of x is an even function. What sort of function? Yeah, even function means it will be symmetric about the y-axis. Then all you have to do is you have to add from 0 to a and multiply by 2. And that's it. I have to explain one more property, which I'm not doing now, because in the next video we will be going through the questions related to these properties. which might come for your exam. So if you like this video, please share, like and subscribe, and I'll be back soon with the next video, and in that video we'll be doing problems based on properties of definite intervals. So till then, bye.